Very good morning to one and all. ஸோ நம்ம எந்த யூனிட் பார்த்துட்டு இருக்கோம் அபவுட் மேக்னட்டிசம் பற்றி பார்த்துட்டு இருக்கோம். அண்ட் லாஸ்ட் கிளாஸ் வி ended with torque, and along with the torque discussed two facts in do you know. ரொம்ப இன்ட்ரெஸ்டிங்காக இருந்திருக்குன்னு நினைக்கிறேன். ரொம்ப இன்ட்ரெஸ்டிங்காக இந்த கிளாஸ் போயிட்டுருக்குன்னு நான் ஃபீல் பண்ணுறேன். ஓகே, அண்ட் டுடேஸ் டாபிக் இஸ் பொட்டன்ஷியல் எனர்ஜி ஆஃப் பார் மேக்னெட் இன் யூனிஃபார்ம் மேக்னெட்டிக் ஃபீல்ட். ஸோ யூனிஃபார்ம் மேக்னெட்டிக் ஃபீல்ட் ஆல்ரெடி ஒரு மேக்னெட் யூனிஃபார்ம் மேக்னெட்டிக் ஃபீல்ட்ஸை ப்ரொடியூஸ் பண்ணி அனுப்பிட்டுருக்கு. இன் தட் பாத் வி ஆர் பிளேசிங் த பார் மேக்னெட். ஸோ வாட் பொட்டன்ஷியல் எனர்ஜி இட் இஸ் கிவிங் அப்படின்றப்போ வி ஹாவ் டு கம்பேர் திஸ் வித் த 11th ஸ்டாண்டர்ட் யூனிட். சரி, 11th நம்ம 5th யூனிட்டில் படித்த சில ஈக்குவேஷன்ஸ் நம்ம டேரெக்டாக யூஸ் பண்ணுறோம். ஓகே, ஸோ 11th நல்லாவே தரவு பண்ணியிருப்பீங்கன்னு நினைக்கிறேன். ஸோ பேஸ்ட் ஆன் தட் வி ஆர் ரைட்டிங். ஸோ there is explanation for diagram. Bar magnet which having the dual pole north and south, length 2L, okay, and it is placed in a uniform magnetic field, and these two poles of the magnet having the equal pole strength P vector, and this magnet is placed in this uniform magnetic field with the angle theta. It is given in diagram. It is very clear in this diagram 3.17. So based on the diagram you can explain yourself. Diagram மட்டும் தரப்போனா நம்ம explain பண்ணிக்கலாம். And here we are going to find the potential energy. For that we are using the torque formula. So what equation we derived in last class, last topic, torque tau vector is equal to Pm vector cross B vector. That is what? Cross product. Cross product is nothing but based on sin theta. Then we can expand that equation as tau B vector is equal to mod tau B vector is equal to mod Pm vector into mod B vector sin theta, and say we are going to find out the potential energy. அப்போ இந்த மேக்னெட்டை நம்ம ரொட்டேட் பண்ணணும். ஓகே, ஸோ இஃப் த மேக்னெட் இஸ் ரொட்டேட் ஃபார் ஸ்மால் ஆங்கிள் டி தீட்டா, ஹவு வி ஆர் ரொட்டேட்டிங் ஹியர் அகைன்ஸ்ட் த டார்க் டவு பி. ஓகே, டார்க் என்ன எப்படி ஆக்ட் ஆகுதோ அதுக்கு ஆப்போசிட் நம்ம ரொட்டேட் பண்ணுறோம் வித் த கான்ஸ்டன்ட் ஆங்குலர் வெலாசிட்டி. ஹவு வி ஆர் ரொட்டேட்டிங் கான்ஸ்டன்ட் ஆங்குலர் வெலாசிட்டி. நம்ம சடனாக ரொட்டேட் பண்ணக்கூடாது, அதே மாதிரி வெலாசிட்டி வேரியேஷன் ரொட்டேட் பண்ணக்கூடாது. வித் த கான்ஸ்டன்ட் ஆங்குலர் வெலாசிட்டி வி ஆர் ரொட்டேட்டிங். Then what is the work done, that we are going to write as the equation. So here there is a equation, tau b vector is torque. So what equation for constant angular velocity? So based on work done, based on last 11th standard 4th and 5th unit, we are using these units, these formulas. dw is equal to tau mod tau external vector into d theta. So what is tau? Torque. Torque into small angle, this one we used in 5th unit. Torque into smaller angle displacement d theta. Okay, இது நம்ம படிச்சிருந்திருக்கோம். So then we are using direct. Then the bar magnet is moved. Where it is moving? How it is moving? Against the torque with the constant angular velocity. Then we can write the tau b vector is equal to tau external force. These two are equal. Then we can write the equation dw is equal to Pm b sin theta. What is Pm b sin theta? Tau expansion into d theta. Then we are writing the total work done. இது வந்து small angular momentum தான் இந்த answer. Then for total work done we are writing the formula w is equal to integration, we are rotating from where to where, theta dash up to theta, tau d theta. Okay, this is what for, this is total work done. We are applying the angle from minimum to maximum. Minimum is theta dash and maximum is up to theta. We are rotating. Then we are substituting tau value in this equation. What is tau? Pm b sin theta. Already d theta is there. We are substituted. Then we are integrating this term. Integration நம்ம 11th இருந்து படிச்சிருக்கோம், மேட்ச்லையும் படிச்சிருப்பீங்கன்னு நினைக்கிறேன். Pmb is taken out. Integration sin theta will become minus cos theta. So integration sin theta d theta is what? Minus cos theta, theta dash to theta. Then substitution minus Pm b, minus already is there. You take that out. Here it comes cos theta. First நம்ம upper value தான் substitution பண்ணுவோம். Cos theta minus cos theta dash. Okay, then this is lower value, lower limit. Then the work done stored in the potential energy in a bar magnet with the angle theta work done is stored means that is called as potential energy. Okay, so W is written as what? U. Then the equation will become minus Pm B cos theta minus cos theta dash. This is the energy stored in that bar magnet. So எவ்வளோ எனர்ஜி இதில் ஸ்டோர் ஆயிருக்கு? U is equal to minus Bm, sorry, minus Pm B cos theta minus cos theta dash. And this is the equation for potential energy when we are rotating the magnet already placed in uniform magnetic field. So for which angle we are rotating that, what work done we are giving from theta dash to theta. If we are choosing the reference point, say the theta dash, the starting angle is 90 degree means, so that second term of the equation will become 0. Okay, and see the equation 3.26. நம்ம ஸ்டார்டிங் ஆங்கிள் தீட்டா டேஸ் 90 டிகிரியை சூஸ் பண்ணியிருந்தோம்னா, மேக்னெட் வந்து மேக்னெட்டிக் ஃபீல்ட் யூனிஃபார்ம் ஃபீல்டுக்கு 90 டிகிரியாக இருந்துச்சுன்னா, ஓகே, அண்ட் தென் we can write cos theta dash is equal to what? 0. Then what is the rest equation? Pm B cos theta. Understood? The potential energy stored in the bar magnet in uniform magnetic field is given by U is equal to minus Pm vector dot B vector. Why dot? Because there is a cos theta, cos now we will use dot product. Do you remember? We are using the dot product. Okay, and the equation for dot product we can write U is equal to minus Pm vector dot B vector. And for that we are giving the three conditions, two cases are explained here. The first case is if theta, the final rotation up to 0 degree வரைக்கும் நம்ம rotate பண்ணியிருந்தோம் அப்படின்னா, so how the 0 degree அது எப்படி இருந்திருக்கும்? In first condition theta is equal to 0 ன்னு கொடுத்துருக்கான் அப்படின்னா, இந்த பார் மேக்னெட், இங்கே இருக்க பார் மேக்னெட் will become like this. This is north, this is south, and see the angle will become 0 degree. அதாவது இங்கே இருந்த மேக்னெட் it will be rotate like this. If it will become exactly flat. If it is flat means for first condition the potential energy value is maximum, that is cos 0 degree will become minus PmB. Okay, minus PmB, it is maximum in opposite direction. Understood? And next one is if it is rotated for 180 degree அப்படின்னா, the same magnet is rotated this direction, then if it comes this side means the angle will become 180 degree. It will be expand now if it comes like this. So if it comes 180 degree, it will be opposite to previous one. If it is 180 means cos 180 will become 1, then the potential energy will become, that is equal to, we can write here as second condition, Pm into B, it is maximum in positive side. So from above two results we can say the potential energy of bar magnet is minimum when it is aligned along the external magnetic field, and maximum when the bar magnet is aligned anti-parallel to the external magnetic field. Okay, so both the cases, both the values are same, but one is negative value. In negative it is getting the negative value, and next one is the positive. Aligned along the magnetic field it is minimum, and anti-parallel to the magnetic field, that is producing the maximum value that we are concluding from this topic. So you can mark this answer for 5 mark question from here, 3.31 page 139 இருந்து next page 140ல example 3.7 வரைக்கும் மேலே வரைக்கும் magnetic field வரைக்கும் ஒரு 5 mark question தரவு பண்ணிக்கோ. இதுவும் ஓரளவுக்கு இம்பார்ட்டன்ட் கொஸ்டின், நல்லா ஃபுல்லாக தரவு பண்ணி வச்சுக்கோங்க. And next is example 3.7. Example 3.7 they are giving question. We are considering the magnetic dipole which is switching on the external magnetic field. We are switch on the external magnetic field. There are two possibilities. என்ன டூ பாசிபிலிட்டிஸ் அப்படின்னா, அந்த மேக்னெட்டிக் டைபோல் பார்த்தீங்கன்னா ஒன்று அலாங் த பேரலல், அலாங் த மேக்னெட்டிக் லைன்ஸ் தட் இஸ் பேரலல், ஆர் ஆப்போசிட் டு த மேக்னெட்டிக் ஃபீல்ட் தட் இஸ் ஆன்டி பேரலல். ரெண்டு தான் சான்ஸ் இருக்குது. தென் தேர் ஆஸ்கிங் கம்ப்யூட் த எனர்ஜி ஃபார் த பாசிபிள் ஓரியன்டேஷன். என்ன பாசிபிள் இருக்குன்றது கேட்டிருக்கா. ஸோ வி ஆர் டேக்கிங் பிஎம் பி த டைபோல். Okay, dipole strength before switching on, then therefore the energy is 0 because there is no orientation. And now we are switch on. So first what is the condition? It is aligned along the parallel. So along the parallel அப்படின்னா first case that is 0 degree. In the 0 degree the formula is U parallel. If it is along the parallel means it is will be taken as minimum minus PMB cos theta it will become U parallel is equal to minus PMB. And then it is anti-parallel, then theta will be taken as 180 degree. Then we can write the equation minus PMB cos 180 degree. What is cos 180 degree? That is minus 1. Then we are substituting here. Minus into minus will become plus. Then we can write here PMB. And this is for anti-parallel. And these two interference are given. So what is cos 180 value? That is minus 1. And cos 0 value is 1. Then we are getting anti-parallel maximum potential and parallel minimum potential we are getting from this example. So after the example 3.7, we are entering into the next topic, magnetic properties. It's topic number 3.4. So why we need this? So why we have to understand the magnetic properties? Why we are having different properties? Why we have to compare the materials with the help of these magnetic properties? All that because all materials are not magnetic in nature, and also one magnetic material, when we are comparing with the other material with having the magnetic property, that are not exactly same. There is some difference. So we need these properties to compare, to identify between the magnets. So it giving some properties to most understandable way. So first we'll deal with magnetizing field. And this magnetizing field is nothing but we are using one magnetic field. So already one magnet is there. That magnet is giving out magnetic field. That field is used to magnetize some other sample or material. That magnetic field is called as magnetizing field. புரியுதா? நம்ம கிட்ட இருக்க ஒரு மேக்னெட்டிக் ஃபீல்ட் ஆல்ரெடி ஒரு மேக்னெட்டிக் ஃபீல்டை கொடுத்துட்டு இருக்கு. வாட் இஸ் மேக்னெட்டிக் ஃபீல்ட்? வி ஸ்டடிட் அரவுண்ட் த மேக்னெட். இட் கிவ்ஸ் சம் இன்ஃப்ளூயன்ஸ், தட் இஸ் கால்ட் அஸ் மேக்னெட்டிக் ஃபீல்ட். அது நமக்கு நல்லாவே தெரியும். இந்த மேக்னெட்டிக் ஃபீல்ட் இன்னொரு சாம்பிளையோ இல்லை இன்னொரு மெட்டீரியலையோ மேக்னடைஸ் பண்ண ஸ்ட்ரென்த் இருக்குது அப்படின்னா தட் இஸ் கால்ட் அஸ் that magnetic field which we are having is called as magnetizing field. And this magnetizing field is nothing but a vector quantity, and it is denoted by the letter H vector. Its unit is ampere per meter. Understood what is magnetizing field? The magnetic field which is used to convert the non-magnetic or specimen into magnetic one. This is called as magnetizing field. Okay, so you can mark this answer. What is called magnetizing field? Up to here with the unit you can mark here. Define magnetizing field is for 2 mark question. And next one is magnetic permeability. Next is about magnetic permeability. So what is magnetic permeability? It is nothing but the ability to measure in the material, the particular material, how much magnetic lines of force can pass through, or we can say in another one way, the capacity of the substance to take the magnetization, or we can say the degree of penetration of magnetic field through the substance is called as magnetic permeability. அதாவது ஒரு சப்ஸ்டன்ஸில் எவ்வளோ மேக்னெட்டிக் லைன்ஸ் ஆஃப் ஃபோர்ஸ் அதில் பாஸ் பண்ணி போக முடியுன்ற ஸ்ட்ரென்த், இல்லை எவ்வளோ அனுப்ப முடியுன்ற கெப்பாசிட்டி, இல்லைனா அது மேக்னடைசேஷனாக என்ன மெஷர் எடுத்துக்குமோ தட் இஸ் கால்ட் அஸ் மேக்னெட்டிக் permeability. In free space, the permeability is denoted by mu naught. Okay, so we are using the symbol mu naught in free space. For any other medium, we are using that as mu. Understood? This is called as magnetic permeability. And one more term in this magnetic permeability, we can define relative permeability. This relative permeability is nothing but the ratio between two permeabilities. One is permeability of the medium, the ratio between permeability of the medium to the permeability of the free space. This equation is giving the relative permeability. So what is relative permeability? Mu r. That relative permeability is defined as the ratio between permeability in medium to permeability in free space. This ratio is called as relative permeability in magnetic permeability. And this relative permeability is dimensionless. Do you remember dimension? Where we have studied? Yes, right, in 11th first unit we studied no dimension. For length or distance means we will use capital L. For mass we used capital M, we used the things, no? Then T, okay, everything we use, no? That is dimension, MLT we used last time, okay? That you remember, okay? And then this relative permeability is not giving any dimension, so it is called as dimensionless and has no units for this, because mu by mu will be get cancelled, no? So there is no unit for this. And for free space means air, or we can take as vacuum. The relative permeability value mu r is equal to 1. Okay, you keep this in your mind while doing sums. We may use in some places. So the free space, air or vacuum, the relative permeability value will become what? Unity, that is equal to 1. And here in this page you can mark two more questions. One is what is magnetic permeability from here up to here. Then definition of relative permeability, that is first question, magnetic permeability. And second question, relative permeability is from here, the relative permeability, okay, up to mu r is equal to mu divided by mu naught. This is another one, two more question. You can mark this. And these two are important just to understand, and then you can write that easily. And next we'll see, next topic is intensity of magnetization. And next is intensity of magnetization, and this intensity of magnetization is explaining here. And we are starting with the bulk material. So what is the bulk material means? We are using the object which having the finite size. Okay, any object with a finite size we are taken here. In that finite size, large number of atoms are there. How many number of atoms are there? Large number of atoms are there. So atoms means mid portion is the nucleus, and around the nucleus there are more number of electrons. We know the electrons are not in a rest. It's always revolving around the nucleus. While revolving these electrons, it containing with orbital motion. The electrons are in orbital motion. So when it having the orbital motion, that electron must possess the magnetic moment, which having the vector quantity. Vector is both magnitude and direction, that we know. Okay, so in bulk material we are chosen the atoms, nucleus, around the nucleus electrons are revolving, so it is possessing the magnetic moment. And if the electrons movement is not in particular direction, if it is moving randomly and magnetic moments value or orients randomly, means the net magnetic moment value is 0 per unit volume. Okay, so what is the net magnetic moment value? It is 0 per unit volume. So in the case of 0 per unit volume, that material are explained here for intensity. And so in random motion it gives net value is 0. Suppose when we are giving external magnetic field with this bulk material, means the atomic dipoles are induced, and here they are try to align along the external field. So there is no random motion of because of the external magnetic field. And here based on that we are giving one definition, the net magnetic moment per unit volume of the material. The net magnetic moment per unit volume of the material is called as intensity of magnetization. That formula is magnetic moment divided by volume, that we can write as Pm vector divided by V. This is a statement for what? Intensity of magnetization. So first we are taking ordinary material, then we are want to align all the electrons because of the external magnetic field. That moving electron is possessing the magnetic moment. We are giving some external. After that electrons are trying to align themselves. At the time, the net magnetic moment of that aligned electron per unit volume in the given material is called as intensity of magnetization. This is one more important two more question. Okay, and this is having the unit ampere per meter, and the formula is Pm vector divided by V. And this answer you can mark from the net magnetizing up to here, and it is vector quantity, and we can write this formula. The SI unit of intensity of magnetization will be taken as ampere per meter. So these 3 points for 1 2 mark question. So what type of quantity it having? Vector, because it is aligned in particular direction. No? So direction magnitude is there, that should be a vector. And in this intensity of magnetization itself, we have one more part. About that we'll discuss in next class. I hope you understood all these questions. And for today's homework, you can write all these 4 2 marks, last 4 2 marks are in the magnetic properties as homework, and you write in your homework and send to me as a photocopy. Okay, and we will meet you next class. Thank you, students.